Hi, I present you this pure hydrogen kit from Hydrobullet Company, a Greek company. This is a product that I haven't found anywhere else. As you can see, it looks like an HHO electrolyzer, but this is not an HHO electrolyzer since we have two outputs, one for oxygen, one for hydrogen. Hydrogen goes into the hydrogen water tank, and then exits there. Getting started with this kit is very simple. Just pour the potassium hydroxide solution provided with the kit into the oxygen water tank. Having already done the filling, I won't do it again, but here I am showing you how to do it. Potassium hydroxide comes in the form of white crystals. We must first dissolve it into water before pouring it into the oxygen water tank. This transparent tube enables us to check the level of the potassium hydroxide solution. Tanks must not be completely filled, but partially. This is the R06 separator kit composed of 6 stainless steel plates. You can buy it on hydrobullet.com website. Here it is. The R06 kit I have can produce 700 milliliters of hydrogen per minute. That's huge. As you can see, the website sells more powerful pure hydrogen kits. Now, let's test it. We are gonna fill a mylar balloon with it, then we will verify that the gas produced is indeed pure hydrogen. How? Once the balloon is inflated, we will measure the lift and then we will burn the balloon at the end. If there is not only hydrogen, we will see it right away. The kit is designed to be powered by a car battery, but here I am using a computer power supply. Voltage is 12 volts. The power supply is plugged into a connected socket, which allows me to measure the power and energy consumed to inflate a balloon with a volume of approximately 22 liters. We will also compare this kit with my PEM electrolyzer. PEM stands for proton exchange membrane, knowing that PEM electrolyzers are known for producing high-purity hydrogen. Inflating the balloons takes a little time, so let's time-lapse. I notice that a tiny bit of water has entered the balloon. It's my fault, so I'm going to inflate another balloon because I want to have reliable measurements. Let's time-lapse. This time no water has entered the balloon. Now let's measure the lift of balloons. The lift of the first balloon filled with the Hydrobullet kit is 9.7 grams. The lift of the second balloon filled with the PEM electrolyzer is 8.5 grams, but there is a little bit of water into it. The lift of the third balloon filled with the PEM electrolyzer is 10.3 grams, that's better. Let's compute the lift with my program and compare with measurements. I enter the diameter of the balloon, which is 34 centimeters. Then I enter the mass of the balloon envelope, which is about 11.5 grams. Here are the results. We get a lift of 11.45 grams, that's pretty close to the measurements. We also notice that if the balloon was filled with HHO, we would have a lift of less than 3 grams. Given the measured lift, it is clearly not HHO. Let's see the electrical consumption measurements obtained. Here are some screenshots of the mobile app for the connected plugs. We observe a fairly similar energy consumption between the Hydrobullet kit and the PEM electrolyzer. Both use slightly less than 200 watt-hour to produce 22 liters of hydrogen, which amounts to just under 9 watt-hour of energy consumed per liter produced. Now let's burn the balloon filled with the Hydrobullet kit. Nice. If it had been HHO, it would have exploded. I release the second balloon. The display of the stabilized power supply shows the voltage on the left and the current intensity on the right. Here I gradually increase the supply voltage. We notice that the amperage is not proportional to the voltage. I made a summary graph showing the amperage. The x-axis represents the voltage, over a range of 4 to 15 volts. We observe a tipping point at 9.8 volts. From 4 to 9.8 volts, the amperage remains low and increases slowly as the voltage increases. However, beyond 9.8 volts, the amperage increases much more rapidly as the voltage increases. In conclusion, I had rather good surprises with this kit. We'll see over time. Next, I will inflate much larger balloons and show other uses for the hydrogen produced. Stay tuned.